In this demonstration, we're going to take a look at the factory method design pattern. A factory is just like a real-world factory in that things are created within and then passed to the outside world. So a car factory creates a car, and those cars that are created are delivered to a dealership. The dealership itself does not create the car. It always requests new cars from the factory. We are going to use a very similar process to make sure that objects that are created, we're going to have a point that's 2D and another point 3D class, we're going to make sure that you have to go through the factory to create these objects. First, we're going to start by adding our point classes. I'll just call it point as far as the file is concerned, and I'm going to put both of my classes within the same file just for simplicity. We'll have an X property, and we'll have a Y property. We'll have a constructor, and the constructors will do the appropriate thing, assigning X and Y. And then let's override toString so that we display X and Y. I'm going to copy point 2D, and we can actually create point 3D as a derivative of point 2D. Since we're going to require X and Y anyway, we might as well utilize inheritance to minimize the amount of work we have to do. We must call from this constructor, one of the base class constructors, we only have one, that accepts X and Y. And then our toString is going to include Z in the output. So these will be our two class types that will be managed by a factory. And as you might imagine, our factory is going to be called point factory. And we'll make it static. That way, when we create our point objects, we don't have to create an instance of the factory first. That's not to say you can't have a factory that is an instance factory. It's just, in this example, it's going to be simpler to make it static. So we'll create a public static point 2D, create point 2D, and we'll ask for an X and a Y, return new point 2D X and Y. And as you can probably guess, we'll have a similar method for creating point 3Ds. We just have to make sure we accept 3 parameters as such. So this is our factory that will create the point 2D and point 3D objects. So back in program main, I will create a point 2D object. I'll call it P2, and I'll set it equal to point factory dot create point 2D, pass it 1 and 2. Then I can do a console write line of P2 since we overrode toString, and I'll do the exact same technique for creating a point 3D. And I'll say create point 3D and 1, 2, 3, and we'll output P3. Let's run the code, and you'll see here's our 2D point and there's our 3D point. So the factory did exactly what we wanted. However, you may notice something. There is nothing in this code that restricts me from doing this. I will create P2A is equal to new point 2D 1, 2. And then I can write that value to the console window, run the code. So we were able to bypass the factory. Now clearly that is not the intent of what we were trying to accomplish. We were trying to restrict creation through the factory. Unfortunately, the way this code is designed, there is no easy way to do this because there is no restriction on the constructor. If I were to go back to point and make this private, now I can't create it here in program because it's private. Actually, let's go ahead and make point 2D private. I didn't create a point 3D from program in the same way. So now you can see the red underline under point 2D, the constructor call, but it's also going to be present in the factory. So we've hamstrung the factory at the same time as this instance here, where we were trying to create it in main. So clearly, just making the constructor private is not going to work. Another possibility is that we embed these points inside of the point factory, make them embedded types, but there are still ways you can circumvent that embedding and still create the objects directly. We could get a little fancy and create some kind of private key that only point factory and the point classes know about, so no other client could create a point directly unless they knew that key. The problem is, since point is defined in this very same project, all you have to do is double click on the source file and see what that key is. So that's not going to do the trick either. For us to implement this factory method pattern correctly, we really do need to create a library to contain both the factory and the objects that the factory creates. Then we can take advantage of the internal keyword and modify the point constructors so that they can only be accessed by other types within the same library. So let's go ahead and create our library by adding a new project to our solution. Notice I right-click on the solution and say Add New Project. And we're going to create a class library, standard one, not for portable use. This is just a standard class library. And we'll call it FactoryLib. And we will click OK. Now, as you can see, FactoryLib is a separate project from FactoryMethod pattern. Also note that FactoryMethod pattern is bold while FactoryLib is not. That just indicates when we hit run, it's going to execute FactoryMethod pattern, which is good because you can't execute a library directly. All a library is a collection of classes, structs, and enums. So let's go back to our point factory class. I'm going to copy the contents, go back to this thing called class 1. I'm going to rename it to point factory. And it's asking if I want to rename class 1 internally as well. And I'll say yes, even though I'm just going to overwrite it anyway. Clearly, it's going to complain about not knowing what point 2D or point 3D are yet. So I need to add another class called point. And then I'll go back to my original point and copy point 2D and point 3D over here. I will make sure both constructors are set to internal. And by doing that, the new point factory can still create these objects because it's visible. I'm going to delete point factory and point from the factory method pattern project, so now all it contains is program. And as you can see now, I have a lot of red underlines because it doesn't know what a point 2D is. That's because we need to add a reference to FactoryLib. I right-click on References inside FactoryMethod Patterns, select Add Reference, select Project, Solution, check mark FactoryLib, and click OK. I can minimize references again, and then I can either type in using FactoryLib, that's the name of the namespace of the other project, or I can right-click on point 2D, do quick actions, and you can see here using FactoryLib is a choice because it recognizes it as one of the references even though we don't have a using directive at the top for FactoryLib. Now that we do, it allows us to use the factory to create the points, but notice now we are not allowed to create the points directly. That's because we don't have access to those constructors because they are internal. You can see it says it's inaccessible due to its protection level. So that is the real way or the correct way to implement a factory pattern such as this so that only the factory has access to the constructors of the objects being created. Now that we've gone through all of this, though, why do we even bother having a factory? What does it give us that calling the constructors directly does not? Well, a factory can be used to tie together business logic from multiple sources. Let's say when you're creating a point, it has to pull information out of different tables in the database. And for the point to be successfully created, all of the tables must agree to what the factory is attempting to do. The factory is a better place to put this logic rather than in the individual constructor because then we are tying in the logic for the back end into objects that are being used on the front end. And we try to keep those things separated. Basically, it's a division of labor. So only the business logic and back-end objects should have access to those details, while the models, which point 2D and point 3D are, should not necessarily know all of those details. It should always be up to a higher source to create them and to dictate how they are supposed to interact with the database, etc. Clearly, with point 2D and point 3D, we don't really require that type of fidelity. But you could probably guess if we had a student factory, and when you create a student, we might require accessing multiple tables where one will contain the personnel information such as name and address, phone number, and then another database table or another database altogether manages their class registrations, so what courses they're enrolled in. The factory would be the best place to handle that type of information because it would have all of the logic necessary while the individual components of student may not, and quite frankly should not have.